Okay, for this question we are asked the factor that will decrease the maximum value of the induced EMF. Okay, let's go through the option one by one. A, increasing the number of turns in the coil, this will increase the induced EMF. So this is not the answer. Increasing the strength of the magnet, it will also increase the EMF induced. And raising the coil, you move the coil nearer to the magnet, so the coil will experience a larger change of magnetic line of force linking the circuit, hence it will result in a larger EMF. So this is wrong as well. D, raising the support of the spring, when you move the magnet further away from the coil will experience a decreased rate of change of magnetic line of force linking the circuit, so it will decrease the induced EMF. So D is the answer. Okay, we are shown the voltage input at the primary coil of a transformer, and this transformer has more turns in the secondary coil, so it's a step-up transformer. So when we choose the output voltage graph at the secondary coil, we should be able to see voltage with a higher amplitude. So C and D, they are out. So A is the answer. Because if you look at B, right, first of all, the amplitude is the same and the frequency of the output voltage waveform has increased. The transformer does not change the frequency of the waveform. So answer is A. Okay, to solve this question, we have to understand that the power of the primary coil is equal to the power in the secondary coil. So the power in the primary coil is equal to VI. This will give us 6 times 1, it will be 6 watts. So to find out which pair of reading is a possible one in the secondary coil, we shall evaluate a third column, which is the power. So option A will give us a power of 0.06 watt. Option B will give us 0.6 watt. Option C will give us 6 watt. Option D will give us 60 watt. So the answer should be C, because the power in the primary and the secondary coil should be the same. To find out what are the factors affecting the voltage across this fixed resistor, right, we can use the potential divider formula. The output voltage, output PD, is actually equal to the resistance of the fixed resistor. I represent it with R, subscript F R, over the total resistance, which is resistance of the fixed resistor plus resistance of the LDR, multiplied by the input voltage, input potential difference. Okay, so if we look at the factors, the brightness of the light shining on the LDR, it will affect the resistance of the LDR. So this is definitely a tick. And the resistance of the fixed resistor is included in the formula, so it will affect. And same goes for the input potential difference. So basically all the three factors, it will affect the output potential difference. So answer is A. Okay, in diagram 1, we are shown an input of maximum voltage 2 volt and frequency 50 Hz. So we see that the amplitude is represented by 1 square and it's 2 volt. So 1 square represents 2 volt on the y-axis. And we see that there's a total of 1.5 waveform. So 1.5 waveform is equivalent to 50 Hz. Okay, now we look at diagram 2. The amplitude is still 1 square, which is 2 volt, and we see a total of 1, 2, 3 waveforms Okay, since the number of waveforms increases by 2 times from 1.5 to 3, that means the frequency has doubled. So it's 50 times 2, that will give us 100 Hz. So the new value of the maximum voltage and the frequency, it should be 2 volt and 100 Hz. Answer C.